Example 1. Greatest common factor, GCF. Here we go. We got the definition. It's GCF stands for greatest common factor. And we're looking for a greatest factor of 45 and 27 that they share in common. So let's start by listing factors of 45. And here's how I do it. I do it this way. What makes up a 45? 1 and 45. Okay, 1 times 45 is 45. What other numbers make up 45? 2, 3. I know that 9 and 5. I know that 5 and 9 make a 45 because 45 has a 5 at the end. And also I know that since 9 is a factor, I know that 3 will also be a factor. So now we just need to figure out what times 3 is 45. Well, it's 15. So the factors of 45 are 1, 3, 5, 9, 15, and 45. Now let's check out factors of 27. So we know that 1 and 27 will automatically be a factors. 2. Let's try 2. 2 is not a factor because it's an odd number. Now 3 is a factor because, here's a trick, 2 plus 7 is 9, and 9 is divisible by 3. So 3 times 9 is 27. Now I'm going to look for more factors. Is there any more? At this point, I don't think there are any. So the only factors are 1, 3, 5, 1, 3, and 9, and 27. We're going to choose the greatest from the common one from this list. So 3 is a common factor and 9, but 9 is the greatest common factor. So that's going to be your answer. Question number 2. We're going to do the same thing, but now this time we're looking at number 14, 30, and 28. Now you're going to have to choose one greatest number from the list from 3 lists, okay? Now 14 is 1, 2 times 7 is 14, 1 times 14 is 14. Those are the only factors I see. 30, 1 and 30, then 2 and 15, and 3 and 10. Those are the only factors of 30. And finally 28. I know 1 and 28. I know it's going to be 2 and 2 times what equals 28? 14. So factors of 28 are 1, 2, and I know that 4 times 7 is also 28. This is my error. So now we're going to choose the greatest common factor, number that's the largest number that's present in all of those. So we know that 2 is present in all 3 of those. What about 7? 7 here, 7 there, but no 7 here. So 7 cannot. 14, yes, yes, no. So the only answer is actually 2 is the GCF of 14, 30, and 28. Now, example number 17, we got 3q minus p, where p equals 6 and q equals 6. There is a multiplication sign between 3 and q, and it says 3q. Now, what we're going to do is we're going to keep rewriting it, but 3 times. Instead of q, I'm going to put what q is, and q equals 6 minus, and what is p? P was a 6. So I'm going to cross those out and write down what their values are. And now, guess what? 3 times 6, you do your PEMDAS. 3 times 6 is 18 minus 6. The answer is 12. Number 18, 3y times x divided by 5. Same process here, same concept. X equals -5, y equals 5. Those values are given to us. So we now need to just rewrite it as is. Instead of variables, we're going to plug in the given values. Instead of y, I'm going to put down times 5. And instead of x, I'm going to put a -5. And now let's go ahead and just start simplifying. 3 times 5 is 15. And you can put parentheses around it. It's not necessary because it's a positive number. Now here is a trick. Minus 5 divided by 5. You do what's inside the parentheses first, which means it's going to be a negative 1. Okay? Now, 15 times negative 1, the answer is negative 15. Okay, here we're combining like terms. Question 35, 5x plus 3x. Terms are alike if they have the same variable. Now, there's a multiplication signs in both of these cases. Check this out, 5x plus 3x. Think about it as $5 plus $3. 5 plus 3 is 8. 8 what? $8. Case closed. 36. Number 36. 5 times the parentheses. There's the times here. 5 times the parentheses, 10 plus 3n. Well, we gotta do first is distribute this negative 5 into this parenthesis and see what's going to happen. So negative 5 times 10, negative times a positive. I'm going to ask my sleepy man for help. So if it's a negative and a positive, my answer is going to be a negative. So I know it's going to be negative 5 times 10 is 50. Again, the negative 5 times positive 3n. Again, negative times a positive is a negative. So it's going to be minus 5 times 3 is 15n. You want to write down variables first, even though this is not a mistake. You can be done right now. But let's be more grammatically correct and say it's negative 15n minus 50. Not a big deal. Example 37. This is the most exciting problem in the whole set. Here is the multiplication sign. And you need to multiply, and keep in mind, you need to multiply not 7. We're multiplying a negative 7 by the entire parenthesis. So we need to multiply negative 7 by 8. And then we also need to multiply negative 7 by, guess what? Negative 9m. Let's get to it. 10m stands by itself because we don't even touch it. Now, minus 7 times 8 is minus 56. Minus 7 times negative 9m equals a positive. 7 times 9 is 63m. Okay, now we need to combine like terms. And like terms are, I'm going to again highlight it, positive 63m and positive 10m. If you don't see a sign in front of a number, it's automatically assumed it's a positive number. Now, 10m plus 63m is, 10 plus 63 is 73m minus 56. Those two cannot be combined. This is an m term. This is a constant. Cannot combine them. This is your answer.